Greetings, students. Welcome to the next screencast, the screencast in which I present to you a real-world problem and we solve it. In this case, we're going to solve it using linear equations in slope-intercept form, the topic of today's screencast. All right, this one's about BMX racing. Here's the question. In bicycle motocross, which maybe you knew was BMX because, yes, we know B, M, but the X is representative of the entire word cross because X are two lines being crossed together. So in bicycle motocross racing, racers purchase a 1-year membership to a track. They also pay an entry fee for each race at that track. One racer paid a total of $125 after 5 races. A second racer paid a total of $170 after 8 races. 2 questions we need to answer. The first one being, how much does the track membership cost? And what is the entry fee per race? We're going to answer both questions separately, but we're going to use, that's right, a linear equation in slope-intercept form to solve them. So let's start with one of those questions. But before we choose which one, let's organize the information that is being given to us. It clearly says one racer paid a total of $125 after 5 races. So we don't know specifically what the linear equation is just yet. We will find that out, but imagine it does exist. We know a linear equation takes in some sort of input from a domain and outputs some sort of number from the range. Well, if we look at it this way, this sentence, one racer paid a total of $125 after 5 races, that means if I'm a racer and I want to do 5 races, in other words, I input 5 races, I'm going to be charged $125. So 5 races is the input into this linear equation, and it will output $125 is what I'm going to be charged, The linear equation will do the math on the 5 races and say, oh, well, you owe us $125 because keep in mind that also includes the membership, which we'll calculate shortly. Based on that exact same rationale, we could set up a very similar ordered pair based on one second racer paid a total of $170 after 8 races. So you probably see where this is going. If I input 8 races, in other words, if I say, you know what, I'm going to do 8 races, then the person behind the counter is going to say, all right, 8 races, each race costs this much, which we'll find out in just a moment, plus the track membership cost, and you're going to be charged $170. So now look what we have here. We have 2 ordered pairs, and we know that an ordered pair is an x and a y coordinate. Very, very nice. And also, just so that we have our information further organized, the way we set it up, the x-coordinate represents, that's right, the number of races. And the y-coordinate represents, yep, you guessed it, total dollars. So knowing this, we can help set up our linear equation in just a moment. Let's answer the second question first based on how we've set it up. What is the entry fee per race? That one we can calculate based on all of our ordered pairs right here. Because to calculate the entry fee per race, we are calculating something called rate of change, which we also know by a different name. It's called slope. That's right. Rate of change, slope, they both indicate the same thing. Slope is for a specific line. You could think of rate of change more involving a real-world situation, such as ours. We remember the slope formula is the difference in y's, so 170 minus 125, because I'm looking at this as x1, y1, x2, y2, so 170 minus 125, divided by the difference in x's, 8 minus 5. All right, so let's do the math here so we get the correct numbers going. 170 minus 125, very good, 45. 8 minus 5, 3, and so therefore we know 45 divided by 3 is indicating 15. All right, now what does that 15 mean? Well, that means it's $15 for every 1 race. In other words, it's $15 a race. So we just answered the second question. What is the entry fee per race? It's 15 bucks. Knowing this, we can answer the second question. All right, now having just answered the second question, what is the entry fee for a race? We just saw it's $15 per race. Remember, that's representing our slope, m. How much does the track membership cost? Now we can answer that. We know that it is $15 per race. Thus, if I raced once, that's $15 times 1. If I race twice, that's $15 times 2. 3 times is $15 times 3. 4 is 15 times 4. You see where this is going. I say this in class quite often. Thus, if we race for some unknown X number of races, that's $15 times X, which is why our slope, 15, is m. So what we can do in this linear equation, which we know in slope-intercept form is y equals mx plus b, is simply remove m and replace it with 15. Voila. So it's y equals 15x plus b. What are we solving for, really? We're solving for b. You see, that's how much is added back on to the 15x. In other words, if I race for, say, 3 races, okay, so that's 15 times 3, 45. Plus, how much extra are they going to charge for the track membership? And that's represented as this extra value plus b. So we are solving for b, which is known as, to us, the y-intercept, and in this real-world situation is representing the extra cost, the track membership, which, as we know, is a one-time fee. It's not like they're going to charge you the membership every single time you go into this track. That wouldn't be very fair, now would it? So, what we need to do is recognize that both of these points have an x and a y coordinate, and to solve for b, we send into y and x only one of the ordered pairs, which of course we get to choose. I'm going to go ahead and choose this first ordered pair as x and y. There we go. That looks more like a y. I'm going to go ahead and choose this first ordered pair, 5, 125, because we could have chosen 8 and 170, but as we all know, our brains are cognitive misers, and we prefer smaller numbers. We would still have gotten the same answer had we chosen 8, 170, all right? So don't think, oh, which one do I choose? You can choose either of them. I'm choosing 5, 125 because, well, you know, smaller numbers. So based on this, what we know is we can replace this y with the 125, and we can replace this x with, of course, the 5, which represents the x-coordinate. Now, one thing we also know is that, well, it's not 155, as we can see right here. We're multiplying 15 times 5, so to indicate to the reader that it's multiplication, parentheses would work just as fine. And now we need to solve for b using the methods that we have been practicing and we know how to do. I mean, this is just basic algebra that we've been doing since last year. First, 15 times 5 we know is 75. So, 75 plus b equals 125. And to solve for b, of course, we subtract 75 from 125, which we know is 50, is equal to b. So what does that 50 represent? Well, that's the extra added one-time fee. In other words, it's the track membership. It's $50 for the track membership. So what we saw are our two answers. How much does the track membership cost? $50. What is the entry fee per race? It's $15 per race. We have answered the question. The next one is for you, and it is similar. Your question is not about BMX, it's about biology, but it will be solved in a very similar way. 4 years after a hedge maple tree was planted, its height was 9 feet. 8 years after it was planted, the hedge maple tree's height was 12 feet. Both sentences, very important. Think back to how we set up a similar two ordered pairs from the previous example. The two questions you must ask. What is the growth rate of the hedge maple? Growth rate. What was its height when it was planted? In other words, when it started. In other words, when it was first put into the ground, how tall was it already? All right, folks, that is your question to solve, which you will do using very similar techniques. Make sure you're answering both questions. Good luck.